Okay, good morning class. So at this point we looked at question 1. Then we got till question 1.6. So with regards to the last lesson, we got up until 1.6, and when I went down I went with the option of saying 45 degrees minus 30. I couldn't manage to get the root of 6 plus the root of 2 over 4 to be equal to the square root of 2 plus the square root of 3 over 2. Okay, so when I thought about this, I got it. Basically, if you take the square root of and I square this number, I actually don't change the value here. Okay, so to apply that there, the numerator is actually a binomial square, which is the square root of 6 plus the square root of 2 all squared. So the square root of 6 is going to be squared is 6 plus the first term times the second term times 2, so it's 2 root. The root 6 times the root 2 is the root of 12 plus the square root of 2 squared is 2 over 4 squared is 16. Okay. So what we have now is we'll add our like terms here. So that's going to give us 8 plus now the square root of 12 can be written as the square root of 4 times 3, which is 2 root 3. Now that 2 times this 2 is going to give you 4 root 3 over 16. As you can see, 4 is a common factor here, so 4 going to 4 once, 4 going to 8 twice, 4 going to 16 4 times. So what we are left with is the square root of 2 plus the square root of 3 over 4. And the square root of 4 is 2. And that's how we can get what they have on the right hand side. Okay. So another way if you had gone with that option. Okay. But I think when the learner came to this point, okay, and they disappointed that we gave them the mark. Okay. But I think most of the people saw it as a double angle instead of a compound angle. I think the double angle is going to be easier to work with than the compound angle. Okay. So we're looking at question 2. The charger for the battery dies. Alright. So yesterday I learned the new word, attach. Okay. So building regulations require the provision of lightning protection for the thatch roof structure. Okay. In the diagram, AD represents, so here we got AD representing a vertical lighting mast constructed on the same horizontal plane as the house. Now I know you guys haven't done this yet. Okay, it's a 3D, what we call 3D problems. Last year we did 2D when we dealt with the sine, cos and area rule. So in this section of work, we are still dealing with the sine, cos and area rule. However, it's dealt with in 3 dimensions. Okay, so this section must still be done. So if you don't understand at this point, don't worry much about it. But for the sake of completing the paper and the video, I'm going to do it anyway. Okay, so same horizontal plane, which means to now say that the foot or the base of the pole is the same horizontal plane as the base of the house, which means to say it's all on the ground. So if something's standing vertical to a horizontal, we know it's always 90 degrees. So AD is then 90 degrees to BD. Okay, although it doesn't look 90, it stands 90 degrees to the horizontal. And you will see them saying that all the time, is standing with these your vertical and your horizontal, or in the same horizontal plane. Okay, so we are told that B and C are 2 points on the ground. B and C are 2 points on the ground. I'm just going to move this up here. B B and C are 2 points on the ground, which are in line with the front of the house, MN, as you can see there, MN. Alright. B and C lie on the circle of lighting projection. So now this is the circle here. So that means to say that BD and DC is your radius thing. You see that? Okay, so that's your radius, which means to say that CBD is also theta then. Okay. Then we are told that BC lies in the circle of the lighting protection provided by the lighting mast. Then we are told that DBA, so it's DBA, this angle, this whole angle here, is alpha, and the angle, DBA is alpha, is an angle of elevation from B to the top of the mast at A. Then we are told that DCB is theta and AB is P. AB is P. Okay, so that's not on the diagram. Okay, so whatever is given now, I filled on the diagram. I'm going to take this away because I need the space here. The first question says, express BD, the radius of the projection in terms of P and alpha. So if you take this into account, that is your right angle triangle, as you can see. Alright? So I'm just going to redraw it here so that you can see it better. So 2.1, we have a right angle triangle there. That is being your 90 degrees, that is D, that is B, and that is A. Remember, that was named alpha, and then your P is lying there. So the question is, they want BD. So if we look at what is BD to the alpha angle, is your adjacent, and you are given the hypotenuse. So which trigonometric function is adjacent and hypotenuse is cos. So you say cos of alpha equals BD over P. So you cross multiply. So BD is equal to P cos of alpha. Okay. You got P cos of alpha there. Okay. Which means to say that DC is also P cos of alpha. Why? Because it's your radius as well. Okay. The next question in 2.2 we asked, hence show that, this is for 4 marks, hence show that BC is equal to 2P cos alpha cos theta. So if you look at BC, BC is that length, which is in triangle BDC. Alright, so with that in mind, we can use the cos rule. Why? Because we have 2 lengths and we can work out this included angle in terms of theta. So firstly we'll start with by saying BCD is equal to CBD, which is equal to theta. No reason required then, because I'll be busy with trigonometry. Only when we're busy with geometry or the question states giving the reasons, then we need to state the reason. Okay. So that is also theta. Whilst angle BDC is equal to 180 minus 2 theta. So that is the sum of triangles there. Okay. So we're going to say that BC squared is equal to, and the rather right here. So BC squared is equal to BD squared, which is P cos alpha squared plus DC squared, which is also P cos alpha squared, because that's your radius there, minus 2 times BD, which is P cos alpha, times DC, which is P cos alpha times cos of 180 minus 2 theta. Alright, so that will give us now p squared cos squared alpha, p squared cos squared alpha, which is going to give you 2 p squared cos squared alpha, minus, we multiply that out, I get the same thing, which is 2p squared cos squared alpha. 180 minus, that's taken you to the second quadrant, makes this negative a positive cos 2 theta. Okay. So as you can see here, let's just take this away. Right, as you can see here, 2p squared cos squared alpha is a common factor. I'm then left with 1 plus cos 2 alpha, or cos 2 theta, sorry. So that's going to be one of 3 that I can choose from. Okay? It's either going to be cos 2 alpha is going to be 2 cos squared alpha minus 1, 1 minus 2 sine squared alpha, and cos squared alpha minus sine squared alpha. But if you look at what we need to end off with is causes only. Can you see that? So I'm going to use the first one. If we had used the second one or the third one for that matter, then he's going to just take you an extra step to convert it back. Okay, so it is going to be at this point easier to go with that being 2 cos squared theta minus 1. Okay. And as you can see, that cancels. And if I multiply this two terms, or those two, we will get 4p squared cos squared alpha cos squared theta. But that is bc squared. But what is the question? The question is to calculate bc. We'll show that bc can be written as that thing. So what do I do from here? Apply the square root. If I introduce square root, is normally plus minus. Because we're dealing with length, length is never negative. So it's just going to be 2p cos alpha cos theta. And there we have proven what they've asked us to do. Okay. But more of this when we get there. Then, with question 3, this is your analytical geometry. As you can see, this group here, at this point we have completed 3D problems and completed analytical geometry with this group already. Okay, which means to say we're quite behind with you guys. But we'll catch up. So again, this section was not done with you. I don't expect you to understand it. But as we know, you just need to finish this here. It says write down the circle center and the length of the radius. So the circle in the standard form is x minus a squared, x minus a all squared, plus y minus b all squared is equal to r squared. While the center is going to be a and b, and your radius of course is r. So if you look at the center of the circle here, which is m, is simply going to be the additive inverse of those. So it's going to be 3 and 1. While the radius, that is r squared, so the radius is going to be 3. Okay. Then now we are told in the next question, in 3.1.2, the question says, I'm going to move this over. 3.1.2 we are told if the length of the tangent from point A, which is t and 7, to point P on the circle, so here we are told it's a tangent. So what do we know about tangent and the radius? It stands perpendicular to each other. Not so, it's 90 degrees. Okay? Tangent and radius is perpendicular to each other. And in a triangle, with a right angle triangle, what comes to mind? Pythagoras. Not so. Then we are told that A is t and 7 is a point on P on the circle is 2 root 13. So So the length of AP is 2 root 13. Okay. It says calculate the value of t when t is greater than 0. So if t is greater than 0, what does that mean? T has to be positive. Not so? T has to be positive. So in pursuit of calculating the value or the value of t, I need to set up an equation here. Not so? So according to Pythagoras, we know that am squared is equal to 2 root 3 squared, 13 squared plus 3 squared. So we put that in the calculator. We open a bracket, it's going to be 2 root 13 squared plus 3 squared. It's going to give us 61. So am squared is 61. Okay. So we haven't picked up t here. However, we can use a distance here. So let's go with am using the distance formula. Am is equal to the square root of. So am is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's going to be t minus 3 squared plus 7 minus 1 squared. Okay, so I'm going to square both sides. So am squared is equal to t minus 3 squared plus 6 squared, which is 36. Alright. So we know that am squared is the same as 61. So I now say 61 is equal to t minus 3 squared plus 36. Take 36 over the equal sign, I get then 25. Is that correct? Right, so that is 25. If I introduce square root, what must I not forget? Plus minus. So 3 minus 3, t minus 3 is equal to plus minus 5. So t is equal to 3 plus minus 5. So t works out to be one of two values. T is equal to 8. So 3 plus 5 is 8. Or t is equal to 3 minus 5, which is negative. However, they told us that t has to be positive. So that can't be the negative 2 value. Okay. Here's another circle geometry analytical geometry question dealing with circles. The equation of the circle in the Cartesian plane is x squared plus y squared plus 6x minus 2y minus 15 equals 0. With R is the center of the circle. The question says rewrite the equation in the form of x minus p squared plus y minus q squared equal to r squared. This is the general form of a circle. Okay. So in grade 11 we taught you how to complete the square. It didn't end there. Okay, with that information we need to complete the square here. So what we say is going to be x squared plus 6x plus a number to complete the square with plus y squared minus 2y plus a number to complete the square with equals 15 plus the first number plus the second number. Okay. So how do I complete the square? I say b times a half, which is 6 times a half, which is 3, and 3 squared is 9. Then I say 2 times a half is 1, and 1 squared is 1. So that is my perfect square trinomial, and that is what I wanted. So it's going to be x plus 3 squared plus y minus 1 squared is equal to 25. So what is the center of the circle, which is your r value? The additive inverse. So it's going to give you negative 3 and 1. And the radius, no, they didn't ask us for that. But I'm going to write it in anyway. So negative 3 and 1. And your radius, of course, is going to be 5. Okay. So the question is to write it in that form. So this is the answer they're looking for there. Okay. So I will need the space here. So I'm going to take this off. Alright. And what was the radius? The radius is going to be 5. Okay, so I'll just draw that in there. Then the next question says, calculate the length of the tangent drawn to the circle from point P. So again, what do? We're going to complete the triangle. Okay, the board is not playing along today. There's your 90 degrees. Okay. So at this point, what can be calculated? I can actually calculate I can calculate the length of arc P. Can you see that, people? So PR squared is equal to the square root of -3 minus 8 squared plus